Hello and thank you for watching my video. My name is Astrid Krasniqi. I'm CCNA and CCNP certified instructor. On this video we are covering new topics added to the CCNA course 200-125, and this is section 3.1 VTP, extended VLANs and DTP. Upon completion of this section you should be able to implement VTP. VTP Overview. As the number of switches increases on a small or medium-sized business network, the overall administration required to manage VLANs and trunks in a network becomes a challenge. Manually adding or deleting VLANs is in the above topology would be time-consuming and may introduce errors. For example, if you have this kind of topology with lots of switches around, it's really time-consuming, or you will have errors creating VLANs switch by switch. You might forget to add VLANs on some switch and so on. So it's better if we enabled a Cisco proprietary protocol which will manage our VLAN database between the switches. Now, VLAN trunking protocol, or VTP, allows a network administrator to manage VLANs on a VTP enabled server switch. The VTP server distributes the synchronized VLAN information over the trunk links to VTP enabled switches throughout the switch network. This minimizes problems caused by incorrect configuration and configuration inconsistencies. VTP only learns about normal range VLANs. Remember, there was a normal range and extended range. So normal range from 1 to 1005, VTP will synchronize your VLANs, not the extended range. VTP stores the VLAN configuration in database called vlan.dat. So we have a server, VTP server, who in there we can create the VLANs, and the VTP server will distribute or will synchronize all the VTPs with the VTP Client mode. So important components of VTP that we have is VTP Domain. This consists of one or more interconnected switches. All switches in domain share the VLAN configuration details using VTP Advertisements. Switches that are in different VTP domains do not exchange VTP messages. A router or layer 3 switch defines the boundary of each domain. Now, what we want to do is have to create the VLANs in one switch, and that switch to synchronize that VLAN that we just created with all of the switches. Now, one of the switch in our topology, we configure that as VTP Server mode. VTP Server mode, you can create the VLANs, delete them, edit them as well, and that VTP Server mode will synchronize the VLAN with all other VTP Client modes. But first thing they're going to check, do we match VTP Domain? If we are not in the same VTP Domain, then we're not going to synchronize our VLANs. Then we have a VTP Advertisement. This is another very important component. Each switch in the VTP domain sends a periodic global configuration advertisement from each trunk port to reserved multicast address. Neighboring switches receive this advertisement and update the VTP and VLAN configuration as necessary. Now, the VTP advertisement, each switch, not just the server but even the client, they will send configuration advertisement to the multicast address. Then they will check the revision number and see if it matches. If it's higher revision number, if you got a new VTP advertisement and it's got a higher revision number, then the information inside that VTP advertisement is newer. So you need to update to whatever the new advertisement says. If the revision number is the same as your revision number, that just means that you are synchronized. If the revision number is lower than the one that you have, you need to reply to that neighbor and say, okay, well, you got the lower revision numbers. Another very important component of VTP is VTP Mode. A switch can be configured as VTP Server, Client, or Transparent. I think the next slide is going to go in depth about these three modes. Now, these three modes are very important. On the VTP Server, which is the default for all the switches, the VTP Server is where VLANs can be created, deleted, or renamed for the domain. VTP Server advertises the VTP domain VLAN information to other VTP enabled switches in the same VTP domain. So as long as they have the same name, they will advertise it. See, there's four modes. We have a client, let's start with server, That's the first one. Client, transparent, and off. VTP Server stores the VLAN information for the entire domain in NVRAM. The VTP Clients, in here, you cannot create, change, or delete VLANs on the VTP Client. The VTP Client only stores the VLAN information for the entire domain in RAM. A switch resets deletes all the VLAN information. You must configure VTP Client mode on a switch. So in the Cisco recommendation is you make one switch as a VTP server mode and all of the switches as VTP Client mode. Now the new different mode is VTP Transparent mode. Now transparent is like autonomous. It doesn't speak to anybody. They have their own VTP, but they don't synchronize it with the server or they don't synchronize it with the client. So transparent switch do not participate in VTP except to forward the VTP advertisement, the VTP clients on VTP server. So if it gets a VTP advertisement, transparent mode doesn't say, oh, I'm transparent, I'm just going to drop it. No, transparent mode, it will forward it to other switches, but it says, okay, but I'm not going to synchronize your revision. I don't care about your revision. My revision is always set to 0, and I don't synchronize your revision. So if, for example, you do want to lower revision from, say, client has got revision 100, and you want to set it back to 0, the first thing is to change the mode to the transparent mode. That will drop the revision to 0 and then change it back to the client mode. VLANs that are created on the transparent mode, renamed or deleted on this mode, are local to that switch only. To create extended VLAN, a switch must be configured on VTP Transparent mode. So remember, we had normal range VLANs and extended range VLAN. Now, normal range VLANs is fine, server client mode is fine. But if you want the extended VLANs, your switch has to be on the transparent mode. So, VTP modes, a bit more in depth. Description, manages domains and VLAN configuration. Multiple VTP servers can be configured as a server. VTP client updates the local VTP configuration. VTP client switches cannot change VLAN configuration. VTP Transparent manages the local VLAN configuration. VTP configuration are not shared throughout the network. In the VTP advertisement, do the respond, yes, participate fully in the server mode, as well as participate fully on the client mode. On the transparent mode, only forwards the VTP advertisement. Global VLAN configuration preserved on restart, yes. On the VTP server, we have saved them on the NVRAM. On the client, they are just saved on RAM. On the transparent, no, local VLANs configuration is only stored on NVRAM. Updates other VTP enabled switches, yes. VTP server, yes, and the VTP client, but no on the VTP transparent. Before we go to the modes, this is a topology that I'm going to be using. So if I go to topology here, so I have 4 switches, 2 layer 3 and 2 layer 2, DLS1, 2 ALS1 and ALS2. So I think I'm connected to here, Control-Shift-6, X on access server, show session. So you'll see I've got connection to my switches. So if I press number 7, I'm getting there to DLS1. So end here and show CDP neighbors. And you can see that I'm connected, well, the router 3, which is not in this section. We're only looking at the switches, so we got connection to ALS1, 2, and DLS2. There's more connections, but I just shut them down. So if I say show IP interface brief, you can see that I did shut down some other connection. It's triple connected to all the other switches. Okay, cool. Now if I say show VLAN brief, right? So here, for example, I have VLAN 10, VLAN 20, and VLAN 34. If I go to router 2, show VLAN brief, sorry, not router 2, switch DLS2, which is 8, and show VLAN brief, they have synchronized the VLANs. Okay, so if I go to switch ALS1, which is 9, show VLAN brief, that's synchronized as well. And if I go to 10, which is ALS2, show VLAN brief, that is synchronized. Okay, how do I know they're synchronized? So it's with VTP. So Control-Shift-6, and I'll go to switch DLS1, which is number 7, show VTP status. So show VTP status gives us a bit more information. So here this switch is capable of running 3 versions. So obviously we have 3 versions of VTP. At the moment we are running version 1. Domain name is Cisco. So the first, it's not default. Default will be nil, nothing, right? So if they have no domain name, then obviously they're not gonna synchronize their database. VTP domain name Cisco. Pruning is not enabled. Pruning is like if, for example, say everyone's got VLAN 10 and this switch doesn't have any PCs connected to VLAN 10. What you can do, you can tell other switches, don't send me any information about VLAN 10. So this switch will not forward any like broadcast or unicast towards ALS1, because ALS1 just told that we don't have anything in VLAN 10. I want to go forward here and move to this mode. See, by default all the switches are in server mode and it's supporting only the normal range VLANs. So if I go, for example, say config T VTP Mode Client. Okay, so if I go to do that for all the switches, so I'll go to do the other one as well. So 8 config T VTP Mode Client, and go to 9 config T VTP Mode Client, and 10. Now this is not recommended to make all the switches VTP Mode Client, because then you can't make any VLANs anyway. But if I just want to demonstrate, I'm going to go back and change DLS2 to the server. But if I do that and I'll try and make a new VLAN, so VLAN 100 says nope, you can't make VTPs on the client mode. Okay, fine. For it to make, sorry, you can't make VLANs on the client mode. So for me to make VLANs, create, delete, edit, I have to set this mode to server mode. So VTP mode server, and then say a VLAN 100. Now it's not a problem. Do show VLAN brief. You can see that now I just created. Did I create VLAN 100? No, I didn't press exit. You see, if you don't press exit, the VLANs are not created. So you have to type exit for VLANs to be created. So let's try again. Do show VLAN brief, and we can see now VLAN 100 has been created. If I go to the second switch of DLS2, which is number 8, and I say do show VLAN brief, that VLAN has been synchronized. The VLAN 100 is here as well. Okay, now if I go back to switch 1 or DLS1 and type show VTP status, what they're going to do, they're going to check for this revision. Every time you create a VLAN, delete or edit this VLAN, this revision number changes, increases. So all of the switches, they check the revision number. So if I go to the second switch, they go to switch DLS2, do show VTP status. You can see it has a revision 6. So if I go to switch 1 and change something, so delete that VLAN that we just created, so no VLAN 100, and I say do show VTP status, now revision has incremented to 7. So if I go to switch 2, I say do show VLAN brief, the VLAN 100 shouldn't be there, it's not there anymore, and then say do show VTP status, the revision has been changed. Now even though if some switch has, for example, doesn't matter if it's in client mode, if it's in client mode it has a higher revision, that will be used. Higher revision always wins. For you to change this revision from 7, for example, say that we go to this client here and say do show VTP status, and it has revision 7 here. Even though it has a revision 7, now you see this switch can't support VTP version 3. If this switch, for example, has revision 17, it's going to win all other switches, because what they do is they check the revision number. So if the revision number is higher than other switches, whatever this switch says, that's what our VLANs they're going to be synchronized to. So if you want to change the revision to 0, for example, you change the mode to transparent. And then if we say do show VTP status, for example, the revision now is 0. So if you bring a switch that has a higher revision to your domain, you need to change revision, make it to 0, right, before you bring it to the production network. And then when we change VTP mode client again, it's going to go to the revision 7. So if I say do show VTP status, right, now you can see the revision 7 because it's been updated from other neighbors. Okay, so if I go to my slides, now the advertisement, summary advertisement, these are sent every 5 minutes to inform adjacent switches of the VTP domain name and configuration revision number. So they check the domain name, Cisco everybody, cool, we can synchronize our database. Configuration revision, yep, change it. Every time we change something, incremented by 1. Then we have an advertisement request. These are sent when a summary advertisement contains a higher configuration revision number. So for example, one switch gets a revision number 7 and his revision number 6. It says, okay, well, can you please send me a bit more hold information because my revision number is 6. Subset advertisement, this contains VLAN information including any changes. So once you receive advertisement request, you send a subset advertisement. The configuration revision number is 32-bit number that indicates the level of revision for the VTP packet. Each VTP device tracks the VTP configuration revision number that is assigned to it and compares it to the received revision number. Each time that you make a VLAN change in VTP device, the configuration revision is incremented by 1. To reset the configuration revision on switch, change the VTP domain name and then change it back to the original name. Well, the best way is to actually put it to the transparent mode and then put it to the client mode. So VTP advertisement, when the switch receives a summary advertisement packet, the switch compares the VTP domain name and revision number to its own. If its name is different, the switch simply ignores the packet. If the name is the same, the switch then compares the configuration revision to its own revision. If the revision number is higher or equal to its own revision, then the packet is ignored. If the revision number is higher or equal to its own, then the packet... No. If the revision is lower or equal, then it's ignored. If it's higher, then it's going to ask... Well, depending on how you look at it. Depends on who's higher. If, for example, this switch has got revision 5 and this switch has got revision 4, and it receives for example, say that this switch has got, okay, if I go back to my slides here, the one that I'm using, right? So let's think this way. Okay, this switch here has got let's bring that. This is revision and it's 5, right? And this switch on this side has got the same revision, right? So the advertisement then sends, okay, well, this switch sends a revision number 5. It says, okay, well, domain name is the same, revision number is same, I can ignore it. If this is for example, revision 4 and it receives it, it says, okay, well, your revision is lower than mine, I can ignore your revision, but then I'll send you my revision, what you should change your VLANs to, and update your revision number because it's old. But if revision number is higher, for example 6, and it receives an update like this, then it says, oh, okay, well, your revision is higher than mine, so I need to change to 6, and please tell me more information. So advertisement request, and then VTP subset advertisement. The subset advertisement messages contain the VLAN information with any changes. When you add, delete, or change a VLAN on the VTP server, the VTP server increments the configuration revision and issues a summary advertisement. On the one or several subset advertisements follow the summary advertisement containing the VLAN information, including any changes. So VTP versions, there are currently 3 versions of VTP available. However, VTP version 3 is out of the scope of your CCNA course. So VTP version 1, default VTP mode on all switches, supports only normal range VLANs. VTP version 2 supports normal range VLANs, supports legacy token ring, supports advanced features including unrecognized type length value, version dependent transparent mode, and consistency check. VTP version 2 is not much different to the VTP version 1 and is generally only configured if legacy token ring support is required. So show VTP status. So this switch that they run this command, you can see that it supports all 3 versions. Version 1 is running. The domain name, this is the default. Well, no, because it says transparent. Default is server, but there's no domain. By default, there's no domain. So if I go to one of my switch, but even if I reset it, even if I reload, it's gonna get, because if it's clean, nothing, and the other switch says, oh, there's Cisco, that's our domain name, then the switch says, okay, fine, I'll take Cisco then. They only don't agree if you set it yourself to be different, right? So then they're not gonna synchronize the domain, the VLAN database. You can see the 255 maximum VLANs supported, number of existing VLAN 12, and we can see the revision number. Can you see the revision number is 0 because it's transparent mode. So VTP details, VTP version capable and running, display the capable and current VTP version. By default, switches implement version 1. Most switches supports version 2. While newer switches, they do support version 3 as well. So we saw in our DLS, for example, when we go back to DLS number 7, do show VTP status, you can see that it does, this supports all 3. Yeah, by default is running 1. So if you're running 2 in one side and 1 in the other side, they are not backward compatible, so they have to be in the same VTP. Domain names that indicates the administrative domains for the switch, so they have to share the same domain for them to be able to exchange. VTP pruning, display whether pruning is enabled or disabled. So pruning, remember, the switch will tell other switches what VLANs he has, and will say, okay, well, don't send me any other information. So if I only have VLAN 1, 5, and 10, what do I need information about VLAN 20 and whatever you have? VTP trap generation, display whether VTP traps are sent to the network management station, SNMP. Device ID, the switch MAC address. Configuration loss method displays the date and time of the last configuration method and the IP address of the switch that caused the configuration changes to this database. Operation mode, whatever mode you are running, server, client, or transparent. Maximum VLANs that you can support. Number of existing VLANs you have, and the configuration revision. Current configuration revision number on the switch. Each time a VLAN is added, maybe you're getting this, a revision and changing. And then MD5 digest a 16-byte checksum of VTP configuration. The caveats for VTP: some network administrator avoids VTP because it could potentially include false VLAN information into the existing VTP domain. Adding a VTP enabled switch with a higher revision number and existing VLAN configuration to an existing VTP domain will introduce and propagate false VLAN information throughout the domain. The propagation can be difficult to correct. What happened here? If I go to this, this is what happened. Like, for example, this switch, imagine this happened in real life. Yeah, so you had this switch had a VLAN 10 and VLAN 20 and 30. Maybe there's only 3 VLANs, 20 here and 30. Now this switch here, down here, let's copy this switch here, right? There was a company who would, like, a testing center and all that, and they were creating VLANs, deleting VLANs, but in the end they ended up being with something like, say, revision 75, and they deleted all the VLAN. They had only VLAN 1, right? So what happened? One of the switches in the client mode broke down. So then they said, okay, well, why don't we just go and get one of the switch from our testing area and bring it to our network? And they did, and they had the same domain name. So that was a problem as well. They had the same domain name, and the problem with this switch is that he had a higher revision. And he said, okay, well, it's a client switch. Yeah, it's a client switch, so you can't make VLANs on it. No, I can't make VLANs on it. Great, let's bring it on. And they brought it on, but higher revision number. So what they did, this switch just sent this revision, and all the other switches says, oh, okay, well, hold on, you got higher revision than me, let me change that to 75, and let me just delete all my other VLANs because I'm wrong. It just should be VLAN 1 only. And that's what happened. Then when you delete the VLANs, all the ports that are connected to that VLAN, they are just like zombies. Okay, without carrying on too much, when a switch is added to a network, ensure that it has a default VTP configuration. There are 2 options for resetting this VTP configuration revision number to 0, change the switch to the VTP domain name to non-existent domain, and then change domain back to the original name, or change it to the transparent mode and then back to the VTP. So to complete the following steps to configure VTP: configure the VTP server, configure the VTP domain name and password, configure VTP clients. We did this. We did the client. So if I can just tell you here, we did the server mode, we did the client mode. We didn't do the domain, which we're gonna do. Configure VLANs on VTP server, and we see it's gonna synchronize. We did that. Verify the VTP client have received a new VLAN information, which we did. You saw it earlier. So confirm all switches are configured with default settings. So here, for example, default setting is there's no domain name. For us, it was a Cisco domain name. So here, for example, VTP domain, and then okay, let's just put capital letter Cisco, right? If I put VTP domain name Cisco here, then it's not going to match with the other guys. So they're not gonna synchronize the database. And we can say VTP password, for example, capital letters Cisco as well, right? So all of the switches now, they have the same name for it to be able to synchronize the database. So if I create, this is my server. So if I create VLAN 200 here, right? Exit, do show VLAN brief. This VLAN is not going to be synchronized with other switches because they don't agree on the VTP domain name, as well as they don't have the password. So if 8 do show VLAN brief, no, the 200 is not there. So VTP domain, capital letters, put it Cisco, and VTP password, capital letters Cisco. Right, now you should see the VLANs. So show VLAN brief. So VLAN 200, well, it hasn't got an advertisement, so we need to initiate an advertisement from DLS1. So say VLAN, for example, what was it? VLAN 200, name sales. So we edit in this VLAN 200, and then we go to the other switch and see if it's got that. Show VLAN brief. So we can see that VLAN 200 now has got DLS2. So VTP mode server, that's the default anyway, and show VTP status, that will tell you what's the status of the VTP. Configure the VTP server, domain name CCNA, and that's VTP domain here, CCNA, password, use capital letters Cisco. The problem with the VTP is even if you have, for example, show running config, I have service password encryption. So it says it should encrypt all my unencrypted password. But when I say show VTP password, my VTP password is not encrypted. So it doesn't work in there for some reason. Step 2, configure VTP clients with the same domain name, same password. Configure VLANs and verify the VLANs are coming on other switches. So if I go to my ALS1, for example, which is 9, do show VLAN brief. The VLAN 200 is not going to be there. The reason is because domain name is different. So Cisco, we have to put VTP password Cisco. Now it's going to get it. But the problem is that it's not going to get it. We have to wait 5 minutes if you want to see it. Or we have to go to switch DLS1, which is, and make some changes. So VLAN 200 name marketing now. Right now we made some changes. Type exit and go to ALS1, and then now we should see it there. So see show VLAN brief. Now we can see the VLAN 200, because unless you make changes you have to wait 5 minutes. Thank you very much for watching. Please have a look at my other videos and don't forget to subscribe. This has been Astrid Krasniqi making a presentation on extended VLANs and DTPs, and as well as in very important VTP. Bye bye.